interface with that stuff. Well, or short of spending like 60K on really expensive hardware to do wider band interception.
Right.
But the overall point is that if you can sniff like the whole ISM band, right, then it doesn't really matter necessarily what that hopping sequence is, right? Because I can capture them all and I can observe it as it occurs.
Yeah, we talked about that a little bit. Like, it's kind of unfortunately in double E school apparently. You know, there's lots of good RF reasons for using it. It allows a lot of things to coexist on the same band without slamming into each other, and that's why it's used actually in a lot of other bands as well. It makes sense because of that, and that also makes it pretty resilient, pretty long range. It's not fast, not super fast, but you know, we have, for example, looked at FHSS 900 megahertz radios that are like 40-mile ranges. You know, so that's pretty awesome for somebody that wants to wire this infrastructure up pretty cheaply. But you do see very much today, even now, vendors that will even use the phrase FHSS encryption, which is my favorite. That's pretty awesome.
It's funny, if you actually go to the Wikipedia page for FHSS, there's like a bullet point on there that specifically says, we should have snagged that, but it specifically says FHSS is a security option, right? That in the entire EE world that we've talked to thinks about it this way. That it's like, oh, well, but you can't sniff it, right? So who cares if the crypto's not good or if there's no crypto or whatever, because you can't, right? How do you know where it's going to be? There's no way for you to do that, and even if you could, you wouldn't know how to put it back together, and you've got to have our secret sauce to know how this works, right? Well, that's not necessarily the case.
Yeah. And yeah, actually, that particular Wikipedia page, there's actually an edit war if you go back and look at the history of like, no, it's not, yes, it is, and then like deleting each other and everything.
Yeah,
so,
and if you're interested in FHSS, also there have been other talks given here in the past. I don't remember if there's any this year, specifically on FHSS for individual devices, and looking at like there's a Wi-Fi 1 and some other stuff. Yeah. But.
And yeah, it's mostly about it's really like good from a design perspective for a lot of reasons, and yeah, the security pieces are just something that it's more convenient from a marketing perspective.
It was designed as more of a logistical issue, right? To let you get over long range without making it easy for somebody to stomp on your signal. So.
Yeah, yeah, and typically that's going to be frequency shift keying that's in place with the various flavors of that.
For this stuff, there's lots of different types of modulation schemes that are out there for everything that from like the wires that are plugged into your house for your broadband or your television or whatever, to this type of environment where, again, very low throughput, very long range, potentially high interference. And when you've got those types of things, what you most commonly see is FSK. So frequency shift keying is very resilient to being stepped on by all kinds of things. So we run into that more than anything else. It's not you will find other types of modulation schemes on some of these devices, but in general, frequency shift keying is the one you see the most.
Yeah, and typically hot patterns and stuff are burned in. Some of the like AMI stuff actually, because it's got more of an actual OS driving these things. You'll see some kind of algorithm they use. Actually, in some cases paired up with things like some other factor like the MAC address, and you use pieces of that or whatever to make the hopping decisions. But for a lot of these like really dumb ones that are just essentially just relaying serial SCADA, those are things where it's just like, here's the 7 hop patterns, and there's usually a default one that's just on the radio that comes from the factory. And when you read the one-page setup guide for it, it just says, did it work? Okay, So yeah, the way that we've spent a lot of time poking around.
Yeah.
No, go ahead.
So 2 major components to interface with this stuff. You need to have hardware and you need to have the software to do it. In the current world of available or fairly inexpensive ways to interface with this stuff, and by fairly inexpensive I'm meaning not 50K, right? Universal Software Radio Peripheral. It's a device. Comes in 2 versions, version 1, version 2. The version 1 is a little bit cheaper. It's older. It's been around longer, so there's more like example code for it. But version 2 has a much wider throughput. Basically, they eliminated a handful of bottlenecks that were in version 1, and version 2 will allow you, for example, to sniff the entire ISM band at once. Right? Being the major draw for that one.
Yeah, and faster clock and different FPGA design, and actually can receive and transmit at the same time. A lot of other neat stuff. But the number one thing that we like about the two is that we can grab a much wider sample. So if we're looking at things that are FHSS, we can pull a big enough chunk that we can get the whole hop range in there, which is pretty nifty.
Yep. Right. So yeah, can listen on the entire thing. There's fun example code in there that comes with GnuRadio. We'll talk about in a sec. That will allow you to, for example, sniff pager data across like all 80 channels or 128 channels or whatever it is. And so that's not necessarily FHSS because it's not hopping between them, but as I guess different carriers use different channels or something like that. And so with this, in one pass, basically, you can grab all of them at once with one device. So GnuRadio, right? That's the primary software that you use to drive this stuff. Open source that actually implements all of the modulation, demodulation, decoding, packetization, all that kind of stuff. All happens within software on this. It's primarily in Python with C snippets that will, well, not necessarily snippets, I guess, but C code that will drive the highly intensive stuff. So if it's got really high need for quick operations, then some of that will be put in there. It's got a very wide API that will do most of the things that you would ever want to do, right? So everything from like packetization to modulation and demodulation, encoding and decoding. And I just as a quick background on what those are, right? Encoding and decoding is about how to map basically zeros and ones that like spit out of something back to data. And there's multiple ways you can do that. It may literally be that it's just 0 to 1, and that a 1 is a 1 and a 0 is a 0, but it may not. There's other ways to do that as well. And then modulation is specifically how that signal is sent across the air. Like when you collect something inside the usurp, modulation is how information is represented within that stream. So frequency shift keying, like we talked about, basically means, so 2 FSK, the one we most commonly see because of the long range purposes and that. FSK basically means that there is sort of like a center channel like this, right, that you would focus on. That would be the center of the channel. And then you'll have 2 that are off to each side that basically it bounces between. And
like
when
that.
You're on, like that.
Like that right there.
Right. So if you were to average everything to the left side of that and everything on the right side of that, they'll basically collapse into 2 points that are to the left and right of center. And as it's on one or the other, that represents information.
Right. And now I have to jump like way back down the
No,
slide.
sorry.
That's okay. But yeah, and like the larger point, like the way I explain it to people is that we all sort of understand that like Ethernet is pulses on a wire. And those pulses then map out to to zeros and ones ultimately, like the difference in voltage on different wires on an Ethernet cable. So you're really doing the same thing with the radio. It's just there's lots of ways to do it, and there's a lot more math involved, and it's a little more complicated, and it's obviously lower lower throughput. But it really is the same principle. You're just trying to get down to to bits at the end of the day. I'm going to see how far back I can go. Don't look. Just close your eyes. Don't look. You didn't see that. Oh.
Is there anything left there?
Yeah, okay, cool.
Yeah. And so yeah, just the overall point about GnuRadio has way more stuff than we ever touched with this and would need. And there's all kinds of interesting things hooked into it, from like doing radio analysis of like stars to tapping into like NOAA weather stuff, and it's all kinds of interesting stuff in there.
Built-in vocoder as well. So if you, I don't know about the auto tune or not, but if you're running a DJ operation or something. So yeah, so essentially, like if we don't know, if we have kind of a rough idea what's going on with something, just the real simple way is that we just sample data and we look for peaks. We get as close to the the target radio as we can.
Yeah, get real close to the signal is the strongest thing you're going to see, and then just watch for patterns.
Yeah, and actually, we've in cases where we've had control of radios, where we can we have control of the traffic stream, we can literally just send one character, wait a second, another character, wait a second, and we can see, visually that those peaks pop out, and that's the hop sequence, right? And once you see that go through and repeat, then you know what it is.
Depending on what type of algorithm they used, it's not uncommon to see one that just loops forever, right? So if you watch it long enough and get that pattern down, then who cares what the algorithm is? You now know what that pattern is that you need to have to speak with a given device or listen to a given device. So.
Yeah, and then what we found, in terms of just cheating, basically, is that there's lots of places where this information will leak. We were dealing with